All right, so what we're going to look at here is I've got a question about confidence intervals. And for this review video, I'm going to kind of talk about confidence intervals from a very general and theoretical standpoint and give you an idea of the kind of question that you might expect on our next exam, exam 3. So what we're going to ask is, let's suppose that you want to know the true proportion of people who voted for Santa Ana in the last election. You sample 950 people and you find 637 of them voted in the last election. You find a margin of error of 0.0299 for 95% confidence, and you construct the confidence interval. Okay? So basically what we need to know in order to do something like this is that at the middle is going to be our point estimate. Okay, we talked about this. The middle will be the point estimate. And then we'll have a margin of error, right? So first I want to figure out what kind of interval am I constructing. I want one for a proportion. So I'm going to construct a proportion interval. And how do I know that? It says proportion. It's either going to say proportion or it'll say a percentage. So proportion interval. So my point estimate is going to be a p hat. That is a sample proportion. Okay, it goes along with our proportion interval. So p hat is going to equal 637, right? The number of successes over n. Okay, that's x over n. So 637 out of 950, and that's approximately 0.6705. All right. Now, all I really need to do is I'm going to take that. That's going to be the middle of my interval. And so what we need to know, what you need to basically have memorized is that your confidence interval is essentially going to be that p hat plus and minus the margin of error. Okay. So we'll talk about first, our lower limit is going to be 0.6705 minus 0.0299. And our upper limit is going to be 0.6705 plus 0.0299. Really important that you're going from right to left, so make sure that your lower one is going to be, left to right. Your lower one's on the left-hand side, your upper one is on the right-hand side. And so this is then going to equal, okay, let's get our calculator out. And you have access to a calculator, so you can do this, 0.6705 minus 0.0299. Okay, so that's 0.6406. And then my upper level is going to be 0.6705 plus 0.0299, and that's 0.7004. So either my true mean is going to be in there or it's not, but I can make a statement. And that statement is, I am 95% confident that the true proportion of people who voted in Santa Ana is between 0.6406 and 0.7004. Okay, so somewhere between basically 64 and 70%, right? That's what that's saying. Now, let's say, for example, I ask you this. Suppose the mayor claims that 68% of Santa Ana residents participated in the last election. Does your confidence interval support this conclusion? Explain why or why not. Well, here's the thing. Here's my interval. It goes from 0.6406 to 0.7004. He's claiming it's 0.68 is the true mean. Now, given how I constructed this, I'm 95% confident that the true mean is somewhere between these two. And he's saying the true mean is somewhere between those two, which is where 68 is. Okay? So basically, our evidence supports this conclusion. Our evidence supports this conclusion because his hypothesis, 0.68, is in the confidence interval. So if we're doing, say, for example, hypothesis testing using a confidence interval, if this value right here, 68%, is actually in the interval, then what we're saying is that, yeah, we believe that that's the truth, that 68%, we have evidence for it. Okay, the idea that it's in the interval, right? If it's not in the interval, and be careful, listen to this carefully, if it's not in the interval, then we don't have evidence to support that conclusion. Okay, and we have evidence one way or another that it might be greater than or it might be less than. All right, so that completes this video.